We've been talking about arithmetic sequences for quite some time. Back row. Too much in mine. We've been talking about arithmetic sequences for some time. Brendan, what is an arithmetic sequence?
An arithmetic sequence is a sequence where you add the same number multiple times.
Correct. You add the same number multiple times. What special letter do we give to that special number?
D.
D. D, correct. D stands for, Jack. Why do we use the letter D for the letter we add over and over and over? It's the common something. Common difference, right, the difference between two numbers. You have to do a subtraction problem to find it. Okay, what is the difference between, no pun intended, between a sequence and a series? Andy. Yes, a sequence is a bunch of numbers with commas in between, just list them. And a series is when you add them. That's when you get a sum, when you get one total answer. Otherwise, you just get a list of numbers. What is a geometric sequence? Maria?
It's where you multiply the same number.
Yeah, multiply the same number repeatedly. What special letter do we use for that? R, which stands for what? Common what?
Ratio.
Common ratio. Good. We have to make a division problem in order to find it. A ratio is a division problem. So, for example, let me start with arithmetic. Tell you what, everybody in here, please write this down. I'm going to make a full chart. Draw a chart like this. There are going to be 3 rows and 2 columns. The first row is going to be a sub n. That's the nth term. The second row is going to be capital S sub n. That's what we call the nth sum. And then the third one, which we have not covered yet, is S infinity. We call the infinite sum. That we're probably going to cover tomorrow. But this is going to be the entire chart for the chapter. So if you're wondering about what sort of formulas do you need to, how many formulas do you need to remember, no more than 6. Can anybody give me the formula for an arithmetic nth term? Go, Brendan.
A over a sub n equals a1 a to the 1
Plus
d
d.
parentheses n minus 1.
Correct. A sub n, sub means below. A sub n equals a1 plus d parentheses n minus 1. The n minus 1 is always there, just forever and ever. Can somebody give me the nth term of a geometric sequence, which you covered yesterday? Look in your notes if you need to. See if you can do it without. Go, Mary.
A sub n equals a to the 1
A1.
parentheses r to the n minus 1.
Correct. To the n minus 1 power. The reason we do that is because it's r times r times r times r times r. Quick question. In both of these formulas, instead of just plain old n, they have n minus 1. 1. Yeah. It's the number of jumps between terms. In all of these, n is the number of terms. And n minus 1 is the number of jumps between the terms. So if you're adding repeatedly, you're not going to add 100 times for 100 numbers. There are only 99 gaps between, so you'd add 99 times. So it's n minus 1. Same thing with multiplying. You don't multiply 100 times, you multiply 99 times to go to 100 terms. Okay? Can somebody give me the formula for the nth sum of an arithmetic? This is also known as Carl Gauss's formula. Yeah.
Isn't it the n over 2?
N over 2.
Parentheses an minus a1, or a1 minus,
Not minus, but
oh, plus,
Plus.
an.
correct. This is the first term, and this is the last term. And then n is how many terms you have total. So it's n over 2, parentheses, first term plus last term. If they give you the first and last terms, this is actually pretty easy to get. We have not covered geometric sum yet. That's going to come sometime today. And infinite sum is probably going to cover tomorrow. See what that is and when it works, when it doesn't. Is it possible to add, actually we tried that in here. Is it possible to add up all positive numbers forever and ever and get an answer that's not infinity? What's that?
Yes.
Yes. And remember what the example? Yeah, 1 plus a half plus a fourth plus an eighth plus a 16th and blah, blah, blah. You remember what the answer was?
2.
It was 2. Right.
Yeah.
So if you,
I do that.
the 1 was a full circle, then 1/2 was a half circle, then fill in another quarter circle, then an eighth of a circle, and it kept getting closer and closer and closer to 2 full dots. And if you went forever, you'd get 2 full dots. You can't go forever, but if you were. Yeah, does that kind of make sense? And that's not the only infinite sum that works. We'll talk about that later. For now, geometric. Let's do a quick example on geometric. Oh, here's an interesting one. One comma negative 3 comma 9 comma negative 27 comma 81 comma ... My first question is this arithmetic or geometric? Yeah. Geometric. Why do you say that?
Because r is -3.
Correct. The way to prove it's geometric is to give me the value of r. They're multiplying by -3 over and over and over. Correct. Can somebody give me the... Actually, let's give me the general formula for a sub n on this one. What's the general formula for finding a term, the nth term of a geometric? Go. Right.
A1 times r
Yep. And what's a1 in this case?
times 1.
It's 1. a1 is just the first term. a2 is the second term. So a1 is 1, parentheses what?
-3
To the power of?
and -1.
Exactly. That's all there is to it. Now, can somebody give me the 10th term? By the way, you might want to grab your calculators, especially near the end of this hour. We're going to be using them more and more. They may need a calculator borrowed for today. 1, 2, 3, 4. I found a whole mess of them. Some of them still have the secondhand store price tag on. So I hope you don't mind.
Just kidding.
So please return these. I 1, 2, 3, 4, 5, 6, 7 here. So what do you think? Okay. 1, 2. I'll save this one because it's junky. There we go. Anybody else? Need to borrow? You got one. Yes. Anybody else need to borrow a calculator? Okay. Scientific calculator is preferred. If you just have one of the old-fashioned ones that just add, subtract, multiply, divide, you might need to borrow one. So the 4 calculators out. Please make sure this one back. All right. 10th term. You're welcome. Just be careful you plug things in properly. There are some, I'll give you some some tips and tricks. Some trips and tricks about how not to have the calculator goof you up. The calculator is relatively dumb. We are smarter than the calculator.
Yeah.
but we have to tell the calculator not to go off a cliff. It's kind of like when you're walking a dog and they get so excited with a squirrel, it could go flying into a hole, saying, arf, 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 ah! Same thing with the calculator. You've got to train it not to go into danger. So, keep going. How do you do that? Go.
-3 times 1.
Yeah, 1 times, which
Negative
isn't going to do
3.
much. -3 to the power of what?
10 minus 1,
10 minus 1.
which is 9.
I would suggest you not type that into a calculator. I would suggest you type 9.
That's what I did.
I'm going to grab my calculator, hang on. And I'm curious what you get as an answer. It's kind of big. What do you get? Yeah, Jack.
Is it negative 19,683?
It is. Negative 19683. Whoa. Negative 19,683. Geometric sequences get very big very fast most of the time. This is why I'm probably not going to ask for the 100th term. It's so enormous it would probably overload your calculator's memory. Questions? Now let's see who can do this correctly. Find me the 9th term.
Mine did error.
I'm going to see who does it. There's about 50% of the people get something wrong about this on a calculator. What do you get? I want the 9th term. Can somebody talk me through it? Go, Tress. What does the formula look like?
It's the same one except for to the 8th power.
Yeah, negative 3 to the 8th power. What do you calculators say? Positive or negative? Positive 6561. Did anybody get negative 6561? Yeah, this is calculator trap number 1. You have to put parentheses around the negative 3 before you raise it to the 8th power. How come? Negative 3 to the 8th power versus negative 3 in parentheses raised to the 8th power. Exponents are what my high school math teacher used to call nearsighted. They can only see what's immediately below them. Here, the only thing it's going to raise to the 8th power is the 3, not the negative. It's going to look like this. Negative 3 times 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 3.
I see.
This one, it's going to be negative 3 times negative 3. It'll be 8 parentheses, which, by the way, will save your bacon. What would happen if you have 8 negatives multiplied together? 8 negatives together make positive. This one, again, the calculator was too dumb to figure out that the negative was supposed to be included. They would come up with negative 6561, which would be wrong in this case. We need positive 6561. Quick question. Can somebody try this? Try the A10 again and type it in like this. 1 parentheses, negative 3 parentheses to the power of 10 minus 1. Try that. And see what you get. In other words, I want to try it today. Good calculator, nice calculator. Right here, we did this in our head, the 10 minus 1. I want to just type it, see what happens. There.
59, 40.
Interesting. You got 59048?
Yeah. It did it wrong.
It did it wrong. That's way wrong. It's supposed to be negative 19683.
I got that.
What
I
happened?
can't do powers in that calculator.
I know what
It
happened.
depends on your calculator too.
It did the power of the 10.
It did, think of the order of operations. What does it do first? Exponent or subtract?
Exponent.
It does the exponent.
So
It
do
does
power of
this first and then subtracts 1 from your answer, which is totally not what we wanted to do. If your calculator, if you have the type of calculator where if you put it in the exponent, does the thing actually rise up? To give you an next one, lucky,
Mine
lucky,
does.
winner, winner, chicken dinner. Now, if you have something where if you hit the exponent key, it actually raises the thing up, you can actually do it. Because if the calculator should do this, if it actually does that, wow.
Use
If it actually does this, 1 times -3, and if you hit the power key and then it has a little blinky spot here, it'll actually do it for you. Because the 10 minus 1 is in the exponent where it belongs. If you just type it in one big string, like the calculators that you borrowed from me would do. The graphing calculators do this goofy thing too. How do you prevent it from doing that goofy thing?
You subtract first.
Put parentheses around the 10
Never
minus 1.
mind.
Oh.
So you raise it to the
I
power
didn't
of
know
this
that.
entire thing. Raise it to the power of this entire thing.
Minus 1.
Now try.
parentheses equals negative 1916.3.
Exactly. Make sense? So those are two calculator trip-up errors, which hopefully you can avoid now. Basically, whenever you put parentheses around something like this, it's generally a good idea in a calculator. Parentheses are free. Use them. You know, if you have like, I wouldn't do this. You know, 2 times 3. This is called overkill.
I'm gonna do that.
This is like, I'm gonna say, all right, fine, it works, but good grief. But if you have any complicated stuff,
6.
putting groups in parentheses is always a good idea in a calculator. Good enough? Now, hopefully, that's not too terribly tough. But now I'm gonna throw a curveball at you. I'm gonna say, here's a geometric
3.
sequence. Go ahead and write this down. This is in your notes. Notes, please. Geometric sequence. And I'm going to give you some data. A3 is equal to 64. A11. Hang on a second. Oh my God. Oh, there it is. Let me see. A11 is 16,384.
But did you just figure that out in your head?
No, I typed it in the calculator.
Yeah, he has a calculator in his hands, but he's just rather uses it.
He's like,
Why use the calculator?
Built-in calculator.
Find R. How? How on earth?
I know. You like reduce, like get like -3 from each of them, and then find that, and then.
Okay, hold on for just a second. Is everybody okay on this side?
8.
Everybody got these in their notes?
Yes.
The 1, 3, blah, 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 blah. Okay, I need a little more space. Let's get rid of this stuff. This stuff. Okay. So how?
Like reduce it basically, kind of.
Like
For the
what?
64, reduce it back to 4. Wait, no, what would it be? Just
Well, 64 is 64, it doesn't reduce.
Well, I mean,
I think I know what you might be talking about.
like, it's kind of hard to explain.
Okay, quick,
Is it 4?
maybe.
yeah.
Now, 64, geometric, what does geometric mean again? Start at the beginning. You're multiplying over and over, right? So we don't have to add to go from here to here, we have to multiply. Is this just one jump? Like from here to here? Did they take just one jump to go? No, they have multiple jumps. How many?
5.
Close.
6. It's 3. 8. No, it's 4.
9.
Okay, now, some people are getting mixed up with the n and the n minus 1. N is the number of terms, n minus 1 is the number of jumps. How do you find the number of jumps between terms?
It's 9.
Minus, just plain old minus. What's 11 minus 3?
9. 8.
8, good save. This is 11 minus 3, better known as 8 jumps.
6 16,000.
That means there are 9 terms, but there are 8 jumps.
20,040.
Here's another question for you. How much did it jump by?
8.
How do you find out? A lot of people are tempted to subtract. They say, well, 16,320. That's if you're adding repeatedly. Say, how much did it jump? You have to see if it's arithmetic or geometric. If they added, then yeah, subtract. If they multiplied, then you divide. So the total jump, what did they total multiply by? That wasn't quite good English, but you know what I mean. What did they multiply by to go from here to here? I don't know. 16,384. Grab your calculator. Divide by 64. This is actually a part where the calculator, you could probably do this long division, but this is a time where it saves time. Go ahead and type that in. What do you get?
56.
256.
No.
So here's my question. 8 jumps is multiplying by 256. Can you give me an equation? Now what is a jump in geometric? What letter?
L. No, what am I doing? N.
L.
N minus 1.
N is how many terms?
R.
R. R is what you're multiplying by. How many R's have you used? What's that? 8. Is it adding? 8 times? It's multiplying 8 times. Ah, maybe. Hold tight. Hold tight.
256 divided by 8.
Whoa, 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 whoa.
It's 20.
Stop. Don't just stab in the dark. It's kind of like closing your eyes in pitch black and pointing your gun in the sky and going blam and hoping you hit a duck. It's like, this is not a good idea. You might hit a plane or something. So, look here. R is what you multiply by. How many times did you multiply? 8. So what's R times R times R times R times R
R
times R?
to the 8.
Ah, that's what I'm looking for. R to the 8th power is equal to, what was the total multiply? 256. Okay, Matthew. First of all, you see we got that. That's the core of the whole problem. It says, how many multiplying jumps did they take, and what was the total multiply? They took 8 multiply jumps, which means you have to do a power. And the total multiply jump was 256. How do you get rid of that 8th power? Yeah.
Radicalize it.
Sort of. A radical is actually power 2.
Square root.
Square root is 2. Cube root is 3. 4th root is 4. Yeah.
8th
8th root. You have to take the 8th root of both sides. Now this one, should I show you this?
Yes. Please, can you please?
Ah.
I actually have it on here.
See if you can find it by hand, by guess and check, and then I'll show you the technique. There is actually a way to do it on a calculator.
Is it 2?
It is in fact 2.
No, I'm so confused.
What?
That's,
Eight.
that makes sense.
What's 2 to the 8th power? 256. It must work. You just found out.
What?
If R to the 8th is 256, find a number that to the 8th power is 256. It's got to be really small. Like if you take 10 to the 8th power, it's enormous. It's like
I press this or press this?
100 million. So it's way too big. It's got to be way less than 10. So 2 is a good guess. And in fact, that is true. 2 times 2 is 4, times 2 is 8, 16, 32, 64, 128, 256. So 8. Does that make sense? Now, there is a technique to do it straight away on the calculator. It's better practice to just shoot at it. It develops your common sense to say something to the 8th power, which is an enormous power, is equal to 256. The answer has got to be way smaller than 256. Way, way, way smaller. I would start at like 2 or 3 if it's something that high of a power. So, does that make sense? And then just try it on the calculator to see if it works. That being said, this next step depends on what kind of calculator you have.
Yeah, I know.
If you have a Texas Instruments calculator like I gave out, or if you have a TI graphing calculator, What type of cigarette is that? What brand? Cassia. Okay, I think I know where the Cassia thing is. Well, I hope.
I think mine can do it.
Do you know where your power key is?
Yeah.
It's, do you have like a shift key or an inverse key? Oh, I see, yeah. Yeah, so this is the exponent
I
key.
set the tax though.
Here's the shift key. You shift and then and that's basically it does the backwards version. Okay, people grab your calculators. If you don't, I'll give the Texas Instruments version first. Do you see where the power key is? It looks like a little hat. It's called a caret, C-A-R-E-T.
What? Wait, where?
On a Texas Instruments, the calculator, the key that looks like that.
I have my hat.
This is the power key.
Yeah, I have a hat.
So if you type 5 and then that power key 3, it would be 125. It's 5 to the third power.
What is n minus and n plus?
That's different. That's storing numbers in memory. Texas Instruments people, we're trying to find, let me grab my own copy. We're trying to find not powers, but roots. How do you find roots? Texas Instruments people, do you see a key in the upper left-hand corner? It's probably blue.
Second.
It's the second key. If you have a different brand of calculator, it might be shift, or it might be inverse. Let me see your calculator real fast. You have a plain calculator. That's non-scientific. You're going to need a scientific calculator for this. That calculator doesn't. Here, borrow this for a bit. Tune back in. Look at me. Everybody, look at me. We are wasting time. Rob, Andy, put the non-useful calculator away, please.
Non-useful calculator.
I'm no offense. Just saying, this one we need a scientific calculator for it. Do you see where the caret key is? That's C-A-R-E-T, the power key. Do second, and then that key. It should get something that looks like, something that looks like that. Depending on your calculator, let's try it on the TI. Let me grab my own. I want to see what it looks like. Yes, Mary, question? In a minute. Okay, good. In order to do the, if you do second, the second key, and then this, that'll give you the root key. Now the problem is, you're going to have to type this first.
Yeah, we tried to do that. Oh, yes.
You have to clear memory.
Then you type this second. Yeah, go ahead and hit the clear button if there's garbage on the screen. Now let's try it. Let's say I want to take the 8th root of 256. Well, look up here. This is the problem I just did. What you're going to have to do, first you have to type the number 8.
It's 2.
Just type the number 8. Don't
Just
blurt it out. Just type the number 8. Now, do this. Is everybody looking where I'm pointing? Is everybody looking where I'm pointing?
Yes.
Type 8, then type this. Second power key.
256.
The second, we're not there yet.
Yes!
And now type 256. Hit enter.
Oh, yes, I did it.
You should get an answer too.
I'm so good at this.
Okay. Note carefully how you do that. Yes, ma'am.
16,308 was 11th power. It's not exactly.
Oh, you took it to the 11th power. That's enormous. Oh, the 11th root. That is 16,384 to the, this should be 8. Yeah, the 8th root. The 11th was the final term we had. Yeah. that's just just get clear 2 or 3 times. I can go to that. Hold on a second.
Yeah, there's bar or whatever.
That's a cat. Oh, that's interesting.
So
Um,
it like adds like 66 to the
Oh, that's wow.
So like 1 plus 1 is like 167.
What? How do you do that? I want to see that.
That's really
Yeah,
interesting.
very good.
You don't know? Look at this, I pulled that.
Okay.
Oh, it's down here, above the division sign.
Look at my calculator. It's so beautiful.
Yes. K is where if you want to do it's a long story. It's where you want to if you want to do the same operation over and over and over again. Your calculator can do that. Kind of if you're multiplying. That can do square roots repeatedly. It can do anything repeatedly. But it's best if you turn it on.
It's good.
Okay, ladies and gentlemen, we have until 10:55. Look my way. Everyone. Everyone. Okay.
Can I have it?
This assignment, no, but thanks for asking. You can borrow it. And if you want me to, I get these at secondhand stores. If you want me to keep an eye out, I will. They're usually like $1.50. So if I get one, I'll bookmark it for you. Let me see. We are looking at homework 17C, but I'm going to modify the homework just a little bit. Take out your homework guide sheet.
Ah!
17C, I want you to do this.
Don't touch me.
Skip 10, 11A, 12A.
Skip those? Good, those are the ones I was stuck on.
Yeah.
There it is.
Those are for a different topic. The next homework, everybody tuned in? Not talking to your neighbor, but listening to me. The next assignment is going to be a worksheet. I'm going to type it up. So, okay. You're welcome. The reason I skipped 10, 11, and 12, we are not doing geometric sums yet. We have not had the notes for that yet. The rest of the hour is yours. Keep in mind, we're getting out of here at 10:55. So you got like 18 minutes.
Wait a minute, we get to go outside in English.
It's 9 a.m. schedule. Yeah, they do have the lunch recess study hall, but they're all shorter. There should be, Andy, number 1, pick that up.
Sorry, Royo.
Number 2, pick up 5 other pieces of garbage on the floor to pay for your sin. Everybody else, go ahead and get busy. Call me if we get stuck. And John, we'll talk to you later. Here we go.